My name is Travis Faske. I'm an extension plant pathologist for the University of Arkansas System Division of Agriculture. In a recent soybean virtual field day, I talked about the importance of southern root knot nematode and host plant resistance in soybean. That is one of our integrated management practices used in the state. Another one is using nematicides. And currently, the only nematicides registered for use on soybean in Arkansas is seed-applied nematicides. So those that are applied on the seed coat of soybean. So here's one that is treated with a nematicide compared to one that is not. So one of the goals that I have is as these new nematicides are becoming available for commercial production is how effective are they? So we can test those in the field, but sometimes to be more uniform, we test those actually in the greenhouse. I can inoculate with a uniform population of nematodes so we can compare side to side which one is better than another one, or if they're at least better than a non-treated control. So what I have set up here is these are some D pots in some sandy soil, and I'm just using a probe here to make a uniform depth, and I'll actually just plant non-treated and treated seed. All right, so those are planted the same. I'll use another small probe to create small cavities around the seed, and that's where we'll place the nematode inoculum. So in this case, we're just using eggs from the southern root knot nematode, Melodogyn incognita, and I'm going to add the same amount to each one of them. So for that, I'm going to use a pipette min. I'm going to mix them up, and in each pot, I'll place 1 ml of the egg inoculum. Essentially, I'm putting 2,000 eggs per pot, which is essentially what we would expect to be our damage threshold in soybean in Arkansas. We would cover each one of these up, water them in, and then wait 45 days to determine, did this nematicide work or did it not? So that's a long time to wait, but we do have some plants here that we inoculated 45 days ago that we're going to go ahead and harvest now to see if we can visually see any difference in that seed-applied nematicide protecting that root system. So here is one replication of an experiment. So I have 5 different nematicide treatments in this experiment, and we're just going to harvest a couple of them, see if we can see any visual differences. Remember, the southern root knot nematode produces galls in about 30 days, so we should be able to see some galls or at least root swellings. So I'm going to pick a treatment here. All right. I'm going to squeeze this pot a little bit. Give it a little tap. Shake off all the soil as much as possible. And then this bucket is just water. And so to help clean off all this sand, we're going to dip it in water, and all the sand falls off. Then I can clearly see the roots. Now, this one, I don't know if it's a treatment or not, but I don't see a lot of root swellings or any gall development. Let's harvest another one. To keep our treatment separated, we use these little tags. Now here again, in both of these cases, these are very healthy root systems, so the nematicide did not have a negative effect, but it's really hard for me to tell any difference. Is this one better than this one? So to know how much protection we had, we can also measure the amount of reproduction that is occurring on these roots from the nematode. For that, we need to go into the laboratory to do a laboratory assay to extract the eggs from these roots, and we can quantify how much protection we've got. If we have a lot of reproduction, we didn't get any protection. What we want is to see fewer galls and fewer eggs on one plant compared to another, and that tells us the efficacy of these nematicides. We're now at the lab at the Lone Oak Extension Center, and this is where we process our roots. So I'm going to unfold these. Here's our tag. I want to keep that separate. And we're going to take a 10-gram subsample. I'm going to chop these up into smaller bits, and this helps with processing and extracting the eggs. So we use basically bleach to dissolve the egg masses, and then we can capture those and collect those in a sieve. So here I have my 10-gram subsample. To dissolve the egg masses, basically we use, it's a dilution of bleach, sodium hypochlorite, and we pour this in. And basically the bleach, as well as the movement of this being mixed up, is what dissolves the egg mass, and then the eggs actually disperse into solution here. So we would actually continue to do this for 4 minutes normally, but we're going to speed this up. And I've got 2 sieves. The top one's going to collect the roots. The bottom one is going to collect the eggs. Turn a little water on here. And I'm just feeling too, I don't feel that bleachy feeling anymore underneath. So I've got a clean sample, and I've washed off all the eggs. Here's actually those roots. We can discard those. So here's our sample. We're going to collect it in this small beaker. Just a little bit of water. We don't want too much. Okay, there we go. And that is the entire step for processing. And in here, we could have tens of thousands to millions of eggs. We'll go quantify those using the microscope. So now that we have extracted the eggs from the root system, I put them into this counting tray, and now we can use the inverted microscope to quantify how many we collected from each root system. Wow, that's a lot of eggs. And so there's different stages of eggs in here, from ones that are almost going to hatch to those that have probably just been developed. And so it'll take a while to count all of these eggs. Let's take a look at this other sample. Move over. Yeah, just initially, visually, both samples have a lot of eggs. We'll have to go through and count each one of those. We may have to dilute them a little bit since there's so many eggs, but that's a normal process that we do for this. So that's how we evaluate the efficacy of seed-applied nematicides, which we share with our Arkansas farmers. Another way that we also test nematicides here in the lab at the Lone Oak Extension Center is their mode of action, how they affect nematode motility. So some of the chemical nematicides actually affect the nematode's ability to move through the soil, and that's what we think is impacting their ability to infect the root system. So I've actually done that before. We do that quite often in the laboratory here, but essentially we take a nematicide that has a very high concentration. Of course, I can't even see the juveniles in this much of nematicide. We dilute it down to a 10-fold dilution to something that may be what is going to be exposed to the nematode in the field, and we can see what effect this might have. And of course, we'd have a control that's water. So I've actually set this up already. We took some juveniles and placed them in this 24-well tray with varying concentrations of a nematicide. In this case, the nematicide is fluopyram. For soybeans, it'd actually be Levo. So let me take a look at these under the scope. Okay, so we're scrolling over to the water control, and you can see all of these nematodes moving. They're all very active. I added a lot more in here than I can count just for the visual to show you today. But all of these are the second stage juveniles. They're all very happy, they're active. The little pointed part is actually the tail, and the clear part is actually the head region. That's where the stylet would be that they would use to penetrate the soybean root. Let's move over to some of our treatments then. I have a blank in here. And then in this one, visually, they're about the same. So this is a very diluted concentration of the nematicide. So they're active, they're just not as active. They're starting to slow down. So again, that's the impact that that nematicide could potentially have in the field. Let's move over to a little higher concentration. Wow, okay. So this is exactly what I wanted to show you. So this is the nematicide at a little higher concentration, so 10-fold higher than the one before. And you can see here, they're hardly moving at all. So the longer they're exposed to the nematicide or at a higher concentration restricts their motility, and so they're not able to penetrate the root system. And so that's another way we assess nematicide efficacy here at the Lone Oak Extension Center. I hope this was educational to you. I hope you found something interesting about it, and thank you.